let me know too, of course, if there's anything, let's say the podium and anything on it in your way. And I already know that basically I'm standing right in front of you, but I'll move as much as possible. Okay, so I'm opening Boole so that, not super excited about this, but what can we do? I'm opening Boole so that we can start working in Boole. Let me move this over. I think we're getting all of it. Okay, so just as a quick reminder, is it the case that everybody's comfortable with the basics of how we use Boole? We know that we can use our blocks language, right? We can use our identity symbol, and we can also use capital letters A through Z to stand for atomic sentences, right? So remember when we're, and I think it's the case that I can't scale this, so I can't make the font bigger, right? So bear with me on that one. But the vertical line that separates the left pane from the right pane is a line that separates out the reference columns or reference sentences from the sentence that you are, for which rather you're constructing your truth table, the sentence for which you are completing your truth table, the sentence for which you are making assessments, right? So let's just do a quick review of, and correct me if I'm wrong, because I have the 1110 folks in mind. Isn't it the case that we discussed on Tuesday the notion, I know we did a little bit on translation, but the notion of truth table equivalent sentences. So does this ring bells? A, B as our atomic sentences, and then as I click over into the sentence pane, something like this. It's not the case, open parenthesis, A, disjunction, B, close parenthesis. And then another sentence. Now, I don't think we did this, so please correct me, or please tell me if I'm right about this. If we want to compare sentences, so two or more sentences are being compared according to certain standards, we take our original reference sentences, in this case, atomic sentence A, atomic sentence B, and after we've made our first sentence, which you may or may not see written as a green number 1 on the right side, right? The green means, yes, you have constructed a well-formed formula. You've constructed a sentence that is not missing anything. It's, if you will, under logic's rules, grammatical. Then if we want to create our next sentence, I used control, or if you're an Apple user, command, or you go to your drop-down menu, add sentence after, and then a second sentence area opens up. So sentence 1 is demarcated, is distinguished, so demarcated by the line, the vertical line, distinguished from sentence 2 by that vertical line. And now I'm going to write negation A, conjunction, negation B. So before moving on, does all of this look familiar, including what we did on the board? Okay, now if it doesn't look familiar and you're willing to talk about what's bugging you, please do.
I have a question.
What are you thinking, Rachel?
So is this like from a homework assignment, so it'll tell you it'll give you those two, or where are you getting those?
Okay, so the first answer is there are homework exercises that ask us to make the evaluation of truth functional equivalence or not, right? But I think more specific or to your needs is the textbook will tell you this is the sentence that you're going to make. So it'll give you the sentence and then you manually type it in just like I did. So remember, just reminder, Boole is the only program of the 3 we use to learn logic, Tarski's World, Fitch, Boole. It's the only program that does not give us pre-given files. You always create a file.
Which is the A and B file. The A and B that like A is T, T, F, F.
Right,
But
right.
that's the only one we make, right?
Yeah, now you can look at the drop down window. You can tell Boole to automatically fill the reference columns and it will. And we're going to talk in a more technical way today about those, about reference columns. It has to do with chapter 4 stuff. But for right now, let's make sure we're clear on the fact that, yeah, you enter in yourself the sentences, and then you will, in some cases, be asked to manually fill the possible values, and in other cases, you can just do an autofill, okay? All right, so now I hope that the following is also just a reminder. If you cast your eyeballs over to the 2 sentences for which we need to construct truth tables, there is, you may not be able to see it clearly, but there is in parentheses a number 1 under sentence 1 and a number 2 under sentence 2. And one of the nice things about Boole is that it tells us which, when you have multiple connectives, is the main or driving connective, right? So the question here is, in sentence 1, is this a negation sentence or a disjunction sentence? In sentence 2, the question is this a negation sentence, the first one, a conjunction sentence, or a negation sentence, the second one, right? So Boole tells you, right, a bit about determining what's known as the main connective or main operator. So as a reminder, or let me ask the question, how are we doing with identifying the main connective when we have multiples? What's our confidence level there? What do you think? So Javier is saying, so. Okay. So quick tip, your main connective is never going to be in a parenthetical. Right? Now, if you have multiple connectives outside a parenthetical, right, you might say, well, that's great, Mia. I know it's not the one in the parenthetical, or if you have multiple parentheticals, it's not the ones in the parentheses, but that doesn't mean I know which one we're dealing with. Well, the next, and it's related to what I just said, the next way you can tell which is the main connective is asking about the scope of a given connective. So think about it this way, your main connective has to tell you about each of the elements. It's got to apply to all the elements. So example, here, and again, I know the font is small, I apologize, I can write these sentences on the board, but here, right, this first negation just covers the A, the second negation just covers B, while the conjunction brings them both together, right? In the first sentence, we know that disjunction's not the main connective because it's within a parenthetical. So the default is, okay, then we've got no other choice, it's the negation. But also think about it this way. The negation is saying it's not this whole thing. So it's applying to the sentence as a whole, okay? And again, as we move forward, this should, and you work more on this stuff, it should make more sense. Okay, so that means, oh, and one other thing, and sorry, Javier, I'm looking at you because you were kind enough to ask to share that you were having a little bit of a struggle. If you say that, or sorry, let me go back here, forgive me. I'm on this little, trackpad is acting weird, I think. Okay, so if you say that the main connective is the disjunction, which I've highlighted, I've clicked in the column under the disjunction, you'll notice that the 2 atomic sentences, A, B, are highlighted. So that's telling you, hey, this is the set of values you need to determine, or sorry, you need to use first to determine the value of the negation, or sorry, disjunction. Then you're in a position to evaluate the negation, right? So when I click in the column under the negation, my reference is the column under the disjunction. I felt like that was really wordy, but does that seem okay?
How do we have the green square?
That green square, Rachel, is an alert that says, hey, I'm the one you need to pay attention to. The truth values here are what you need to pay attention to.
First you do the negation in order to get that, no?
First, you have to work the disjunction. So let's go back here, and I think I was in front of you, so let's try. Okay, so if I click under the disjunction, do you see the green highlights?
Yeah.
That's telling you, hey, these are the values that you need to use to determine disjunction. Then when you're done with that and you go to negation, you're told now, here are the values, by way of the green highlight, that you use to determine the negation. Okay? All right, so what do we know about a disjunction? A disjunction is false when and only when each of the disjuncts is false. So our values are going to be what? True, true, true. Yay! Okay, now we're in the position to reject them, right? By definition of the negation, we're going to say what? Awesome. Now we're in a position to move over to our next sentence. Now I just happened to click in the column under the second negation. There's no order of operations that forces us to construct determine the values for the second or the first negation first. Doesn't matter which one. You do have to work each negation before you work the conjunction. So we're going to take the definitions you already know. What are you going to, oops, let me come up to the top. All right, so negation true is, negation false is, negation true is, negation false is. See, it's just like second grade. And I don't mean that to infantilize you. All right, so here, what are we doing? False, false, true, true, if I can find the key. Good. Now we're in a position, let me get out of the way, because again, I'm right to think that my body is in your eye line when I'm at the computer, right? You know what I mean? Okay, so a conjunction is true when and only when each of the conjuncts is true. In all other cases, therefore, it is false. So false, 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 true. Okay, now, here's another nice feature of Boole. If you go over to the far right set of buttons, verify table or verify row, if you want to make sure that your truth table has been constructed correctly and completed correctly, you hit verify or click verify table, and look over in the far left in that pink strip, you get a check mark next to correct and a check mark next to complete. Woo! Yeah, Rachel, what are you thinking of? Alejandro, what are you thinking of?
Oh, to be honest, like I don't get. I thought so. Disjunction is if both of them are false, then it's false.
False, correct. You're thinking of it canceling out, I think.
I thought like if they're both false, doesn't it make it true?
No, that's what. Hold on to that thought.
That's why I'm confused with the T and S because I'm like I'm getting it. Everything that I think it is, it's the opposite.
Okay.
So it's not like I get some, I don't get any. It's like completely the opposite.
Okay, I don't hear that from you all the time, but I trust you that you know your mind better than I know your mind.
Yeah.
So two things. One is we are going to understand from the standpoint of a truth table how effectively a double false makes a true. So hold on to that. We'll get to that one next. But I can say this. Let's think about our ordinary understandings of the disjunction, right? So if I say Felipe is wearing a cap, and we all stare at Felipe and you say, oh, it's true, Felipe's wearing a cap. It's true that Felipe or someone else is, right? So as long as one side of the disjunction is true, the disjunction is true, okay? So, you know, he could take off his cap and then we'd have to look for somebody else who is wearing one if we want that sentence to be true. Of course, if we have two people wearing a baseball cap, it's still true because it's true so long as at least one is.
Okay.
So notice that language. So long as at least one is true, the sentence is true. Now, if I say it's false that Marilyn wears a ball cap, we stare at Marilyn, it's not the case, she's wearing a ball cap. You know you're not wearing a ball cap. Is it true that at least one of you is? No. So it's false you are, it's false you are, so it's false that one or the other is.
Okay.
Right? I know I did that quickly, but I think you're comfortable with the example.
That, and also, I thought that we were trying to solve what, like, I get confused on, like, which line we're doing first. Because I thought you said that you wanted us to figure out whatever applies to the entire thing. So
Yeah.
for A, or like number one, that number one sentence, the negation, that applies to the entire problem.
Right.
And for number two, is it the conjunction that applies to everything?
Right.
But you don't start with the negation on number one, but you do start with the conjunction. For the second. So that's why I'm confused.
Yeah, okay. So this is another reason why it's great for you to talk through stuff that bugs you. It gives us an opportunity to hone in on a legitimate confusion, right? And to revisit the idea maybe in another way. Hold on to that for half a second because I think we need to address it. Alejandro and Javier, are your questions similar or different?
Different.
Okay, if you'd ask your questions, then we can figure out together how we might want to proceed.
Well, how do you prioritize if you have three variables, if I have the C in there?
Okay, if we have three atomic sentences, the first response is we will have an increase in the number of rows. The number of rows increases exponentially by way of the number of atomic sentences. If you had another atomic sentence in here, we would need to have another connective, given the existing sentences.
But how would you prioritize which one goes first, though?
Oh, I'm sorry. Great question. So will you hold, please don't forget that. That's a hugely important question. Let's do this very quickly, just so I'm clear about what you're asking. How, when we start setting up our table and we start with our reference columns, I think Alejandro's saying, well, which do we do first, right? In other words, what's the order that we put them in? And the standard is this: the order of your reference columns follows the order of your notation, the sentences in your notation, if we read left to right. So, but hold on to that because we need to push on that a little bit more. Great question. Javier, how about you? What are you thinking?
I was just wondering if it was too much, if you could write the rules on the board.
The truth definitions?
Yes.
Yeah, no, that's not at all too much to ask. And in fact, do you want me to just put the shorthand on the board? Can't do that for negation, but we can do it for conjunction and disjunction. And then if you say, no, I don't like that, then we'll put the full definition set up. Here's what I have in mind. So some sentence P is true or false, right? Some sentence not P, and I'm gonna try to highlight this with blue so that is the opposite, false or true. Yeah? Now, if we have two atomic sentences, I'm just using P and Q now. Notice I'd use A and B, but I'm using P and Q. Doesn't matter, capital letters, A through Z are atomic sentences. And we have, and they always lay out this way, the possible truth values. For the first one, half true, half false. For the second one, alternate true, false, true, false. Okay? Now the definitions. P conjunction Q, and again, I'm just going to give us the shorthand.
This is an example, right?
No, these are the definitions. And of course, I'm writing one of them erroneously. Hold on. A little typo there that makes a big difference. Okay, so a conjunction is false when and only when each of the conjuncts is false. That was a disjunction, just stop. When I do stupid things, and by stupid I only mean when I say something but I mean something else, what I am saying and writing do not comport with what I mean, whose job is it to correct me? Thank you. And don't worry, on the assumption that our recording is going okay, I'll leave this in the recording because the reality is it's important that you know that we mess up. And here's the really cool thing about messing up in logic is under most circumstances, you know, I'll get caught out messing up by the truth table, right? So I want you to hold on to that because I want you to know that you're not alone in doing this work. This is a rule-governed system so that if you mess up, you'll get caught out. You'll get corrected. Being corrected is a wonderful thing. I don't want to go around with false beliefs, do you? Ew. Okay, so P conjunction Q. Sorry, so Javier, Javier, we're back. So a conjunction is true when and only when each of the conjuncts is true. Yes, thank you. How about a disjunction? A disjunction is false when and only when each of the disjuncts is false. Now, I come back to my question from earlier. Javier, do you prefer the whole table or is that shorthand okay?
That's okay.
Yeah, okay. Okay, so let's now come back to Rachel's question. And what I would like to do is offer you an example. And let's see, I'm going to turn this. I don't know if this will work. I'll turn this to see if we get our board here. Okay. I want to try this. You guys are going to tell me whether or not this works. What's the this? Let's review Rachel's question. Rachel says, look, let's just take sentence 1 for right now. If the main connective is the negation, why don't I deal with those values? Why don't I calculate or determine the values for negation? It's the main guy. Here's the short answer, and I hope that the example I give you makes sense. You can't determine the values of the main connective without first dealing with the subconnective or subconnectives if there are multiples, and without dealing before that with the possible values for your atomic sentences. So are you ready for my example? All right, so I'm going to take the same sentence, not parenthesis A disjunction B. And what if I tell you that this negation sentence is true? So now I'm working backward, right? This is one possible scenario. If negation or, so if not or, if neither nor, if not either one or the other is true, that means that the disjunction must be false. And if the disjunction is false, I'm working backward, that means that each of A and B must be false. Quick temperature taking. Yay, you liked it? Or, oh my gosh, me, you just made everything worse. I don't know where to stand to be out of your way.
Okay.
Okay, so Christian, that's kind of comfortable. Was that you or who was that?
Yeah.
Yeah? You're okay with that? Good.
Yeah.
Rachel, what are you thinking?
So I thought that you started off with the conjunction in sentence number 2. You didn't, right?
Correct.
That's what I thought. I thought you started off with the main thing on number 2, and then you didn't on number 1, which made me confused.
Okay.
I get it if you because that's what you're trying to look for, so that's the thing you do last, right?
Right, yeah, beautiful, good for you. And by the way, maybe I should move my water bottle a little bit too. The way you're articulating these ideas, I think, I hope it's the case, is really, really helpful, right? Because you're honing in on what's bothering you and why it's bothering you, and very concisely articulating that. So good for you. Thoughts so far. So what are we thinking in terms of constructing the truth table with respect to determining the values of a subconnective and then using those values to determine the values of the main connective or main operator? I know some of you are like, yeah, Mia, I know, I got it, I'm gonna go to sleep. That's great, that's fine. I'd love to know how you think about this so that you can share that and maybe help somebody else. If you're saying, yeah, totally, it makes perfect sense. Is there a way you want to articulate that? Or is there a way you're willing to articulate it? Okay, no worries. All right, so now let's move on to the following concepts, and I know that I'm jumping over to chapter 4, and I haven't yet got to Alejandro's great question, and we will. But one of the things that we were doing on Tuesday was talking about how sentences are or not equivalent. So one of the things I want to say before talking about is the following. If you look at the values under each of the main connectives, right, is there at least one row on which the sentence is true? So take a look at sentence 1, main connective. Is there at least one row on which the sentence is true? Yes, I see one nodding, couple nodding, good. So the main connective is your negation, right? So it looks like we've got the 4th row, a value of t. We'd say that this sentence is contingently true. It's true sometimes. Another way to put it is to say it's true sometimes. The technical way that we'll talk about it is that it is truth table possible, or it is a possible truth, right? It is possibly true, okay? How about, we already know since they're equivalent, what we're going to say about sentence 2, but isn't it also the case that sentence 2 is possibly true? In other words, there's one possibility where it comes out true. Yeah, okay, good. Now, I'm going to go under assessment, and when I click on assessment, I don't know if you can see this well. You know what I just realized? I did this before, didn't I, where it was fuzzy the whole class, and toward the end of class I went, oh yeah, I didn't. I didn't, what's this called? Focus. I didn't use focus. Isn't that better? A little bit. You'll be glad to know that on Tuesday, I dropped my laptop. I was using it to record. I dropped my laptop, and everyone was like, right? And then I said, oh, don't tell my husband. He's IT at home. He'll freak out. So then I was editing up the video, taking out that part last night. But like a dum-dum, I did it in front of him in the kitchen. He's like, what did you just do? Did you just drop your computer? No, I didn't. I lied. But he knew I was lying. So. All right, so here again, Mia's doing something that's not the best, which is, she could use focus and she didn't, and now I'm talking in the third person like the royal we, and I'll stop doing that. Okay, we've had enough of a break now, we can refocus. Notice that we've got under, in this assessment, we've got 2 options. I want us to look just at the middle option, right? Did we say that the sentences are truth table equivalent? Which is to say, if you look at the main connective and you look at the column, the values in the column under the main connective, they say the same thing, right? Okay, so we got thumbs up, we click, these guys are tautologically equivalent, and we click OK. And now we're going to, in the upper right-hand corner, verify, assess, and we get a check mark. Right? Does that make some sense? So far, so good? Now, I also asked you to look at just sentence number 1, and what I'm going to do now is erase, I think, oops, sorry, the cable's in the way. So table, I'm going to delete the column. Okay, now I want to go back to assessment. Do you notice that because there's just a single sentence, that second option is now not available, right? So you cannot assess a single sentence as being equivalent to itself, right? That doesn't make sense. I mean, it's reflexively the case, but we don't have that as an assessment. But notice we've got 2 other options, one of which we just talked about, and that is TT possible. So when you say that a sentence is contingently true, we're saying that the sentence as being true depends on or is contingent on the possible values that make up that sentence in that instance. So look at row number 4. The negation is true when the disjunction is false. It's not true all the time, but it's true in that one case. So we would say that it's contingently true, which is to say that it is a truth table possibility. It's truth table possible. It's possibly, it is true in one possible world. Yeah? Now, that other assessment says, talks about a tautology. So here's another definition to throw at you. We'll work on it together, but it's going to be, I hope, fun for you to start thinking about truth in this additional way, and then comparing it with some other ways we can think about truth. That is, including a way that we already have done, which is the Tarski's world notion of truth. Or that's not entirely accurate, but it's a version. Part of it is accurate. So to say that a sentence is a tautology, or to say that a sentence is true in terms of a more broad, logically true sentence, is to say that that sentence is always true. There is never a case when that sentence is false, right? So since we have 3 out of 4 possible cases coming out false, we would say this sentence is not a tautology. Yeah? So we click, not a tautology, we click OK, and now we're going to verify the assessment, and we get a check mark under assessment. We're correct on both counts. If we were to say, on the other hand, that the sentence is a tautology, and we click OK, and we verify assess, we get an X. So again, one of the nice features of these programs is that they do give you some immediate feedback, right, on some of your work. Okay? Right now, before moving on to talk a bit more about the notion of logical truths, or logical necessity, I should say, I want to make sure that we address another equivalence that we looked at. So I'm going to delete this column, and I'm going to delete this reference column. And then we're just going to be left with A. Question for you: with one sentence, one atomic sentence, we have how many possible values? A sentence is either true or false. So we write T, we write F. Now over here we're going to duplicate this sentence, A, and then we're going to generate another column. I'm trying to do this upside down without much success. negation, negation, A. Blah, 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 where'd it go? All right. So we already know that A is either true or false. So just a reminder, when you're dealing with an atomic sentence, that is a sentence that doesn't have any connectives involved in it, you're just going to repeat the values from your reference column. So true and false. Now let's go back to the point that Rachel made earlier when she's thinking about the main connective, right? She wants to deal with the main connective, yes, but can you see that before we deal with that second negation, we have to deal with the first? Yeah? So we click under the first negation, and we see that we're going to reject the value of the first row, which then becomes what? False and true.
Is this the first or the second? The one close to the A or the one furthest?
It's the one closest to the A. I know that it
That's
doesn't
why
look like
I'm
the
confused.
columns are like, yeah. Well, oddly enough, and if I'm not mistaken, this is not the brand newest version of Boole, but whether it's, I hope I'm not wrong about this, actually I hope I am wrong about this, whether or not it's the newest version of Boole, you can't scale, you can't make the font bigger without messing up the column or, structure. So the best you can do, and I don't think I even tried to make this larger, but I do recognize that it looks like they might be a little off. The best you might be able to do, I think, Rachel, would be something like this. Go into your sentence and maybe put a space bar between, right? So you get a little bit more daylight between your first and second negation. Okay, so now we're saying not false is true, not true is false. And we're going to say, we're going to ask if these two sentences are, if the table rather is constructed and completed correctly. We get 2 check marks. Okay? Now we're going to work our assessment, and I'd like to throw out before we move on, just so that we've sort of got it in mind as we move forward. I want to look at the last assessment. We haven't done that yet, but first, yay or nay, is sentence number 1 tautologically equivalent, truth table equivalent, the same as truth functionally, not A?
I don't even know what that means. What is tautological?
What do we think? Somebody who feels comfortable, tell me what truth functional, truth table, or tautological equivalence is. I know some of you know.
The same thing?
Yeah, so the values are the same, or the two sentences say the same thing. Thanks, Alejandro. Does that help a little bit?
So the first would read, the last sentence is or is not the same as the others. Is that how it would read it? How you
Yeah,
read it?
so sentences 1 and 2 are or are not truth table equivalent. And notice I'm putting my fingers under in the column under the main connective here.
Okay.
Yeah?
Yeah.
So yes, true, yes, false. They say the same thing. They have the same values on each row of the truth table in the column under the main connective for sentence 2. That's what we're looking at. Yeah? So we say yes, they are tautologically equivalent. Now, question for you. If 2 sentences say the same thing, couldn't you substitute one for the other? Yeah? So is it fair to say that if I have one, it follows that I have the other, and vice versa, because they're equivalent, they say the same thing. Okay, so here's our last concept. The last sentence, that is sentence number 2, is a tautological consequence of the other. And because they are tautologically equivalent, right, the first sentence is a tautological consequence of the other or others. So I'm going to click OK, and then I'm going to click Verify Assess. Woohoo! And we get a check mark. Right now, I recognize that for some of you, the sticky wicket here, the fly in the ointment here is the technical language that we're using. So what I would like to do before we move forward is just to remind ourselves what we're saying. When we say that a sentence is a tautology, we're saying that that sentence is true on every row of the truth table. And let me get a little bit more granular. When we say a sentence is a tautology and there are multiple connectives in that sentence, we're saying that that sentence is true on every row of the truth table in the column under the main connective, because that's the one that we care about evaluating. Tautology. Okay. 2, tautological equivalence, aka also known as truth table equivalence, also known as truth functional equivalence, right, says two sentences, could be more, but typically we're talking about two sentences have the same truth values on every row of the truth table. Let me get more granular. If it's the case that you have multiple connectives for one or more of those sentences, you say two sentences are tautologically equivalent when they have the same values on each row in the column under the main connective. Identical values, right? Lastly, for those of you who might be a little concerned about tautological consequence, we're talking about an argument that's valid. Easy peasy, right? Do you believe me?
It just sounds like you're saying that it needs to be true and true going down on that line, like one column, right? That's what it sounds like.
Wait, stop. I'm sorry to interrupt, but let me stop you there. For what? For this last concept, for validity?
When, like, the assessment, like the second question where it said,
Here, let me bring it back up.
it says sentences are or are not tautologically equivalent.
Yes.
It, like, I don't understand, you put are, like, it sounds like you would think, or I think it would mean, like, it's true going down the column, but there's not one column on there that says true. It's true, false, true, false, true, false, false, true. Like, it's not.
Equivalent just means the sentences have the same value. So let me, hold on for just a sec. Let me cancel out of here. Let me get rid of the sub values here. So, okay. Is it fair to say that on row number 1, the two sentences have identical values?
Sentences are going across, and it's just going to be on 1 and 2. It's not going to be behind that on the left side, right?
Correct. Yeah, because this is just reference.
Okay.
Okay? Sentence 1 and sentence 2 on row 2 have identical values.
I get it now.
Yeah?
Yeah.
Okay. And then for consequence, tautological consequence, I want to give you another example. But basically, just so bear this in mind when we work through another example, I want to give to you, let me start that sentence again. So I'm going to give you an example of another example of tautological consequence that has nothing to do with equivalence. We're not going to evaluate equivalence. What I want you to bear in mind is we're talking about an argument that's valid. Okay, Alejandra, what are you thinking?
Can you just think algebraically? Like if I give a value of 1 equals negative 1.
Yeah, so you're thinking about like, some people want to construct truth tables using zeros and ones.
No, just like if I'm trying to validate this.
Oh, I see. Oh, I'm sorry, forgive me, yes.
The value of 1.
Yeah.
1 equals negative 1.
Yeah.
That's how it.
Yeah, sure. Yep. Yeah, you'll find, I mean, we didn't, so what I'm about to say I think is a relative of what you've just said. we didn't cover the section of chapter 3 where there's talk about alternate notation or alternative notation. And I think you may have remembered Chris, for example, was saying, when I see a negation, I think, of the notation that we use in coding where we're using an exclamation point and it goes in a different place, and it's like, yeah, so that's just a different way of talking about the same stuff. It's like moving from, I know there are translation issues, but for the sake of the point here, it's like moving from, let's say, Mandarin characters to English language characters. All right, so let me offer the following. I'm going to create or just generate a new window, not two, just one. And I'm going to, and Alejandro, we have not got to your awesome question yet, but it hasn't been forgotten, I promise, okay? I'm going to use, once again, A and B, and then I'm going to construct 3 sentences, and I'm going to ask us just to focus on whether or not the third is a logical, aka in this case, tautological consequence of the first 2. So A or B, not A, so B. All right, I'm going to, for the sake of time, just ask Boole to fill the reference columns, and we have A, true, true, false, false, B, true, false, same as always. Take a look at sentence 1 and sentence 2. You'll see that there's just one connective. So we don't have to worry about the question of what do we do first, right? We simply churn out what we know are the values based on the definitions of each of the connectives. And then lastly, what kind of sentence is B, compound or atomic? Sentence 3. Is there a connective involved in sentence 3? Nope. So it's atomic. So whenever you have an atomic sentence in a truth table, you simply carry over the values that are in the relevant reference column. Okay. All right, everybody. If I can get the thing to go in the right place. What do we know about a disjunction? A disjunction is false when and only when each disjunct is false. So tell me. Awesome. The negation always rejects the value of the sentence it's negating. So we get false, false, true, true. Awesome. Okay, now, oops, let me go over here.
So
Marilyn, what are you thinking?
For 1, 2, and 3, like the top part, did you just make that up? Like, for example, you would have seen that in the book, or how did you get the A disjunction B?
Great question. Yeah. So I'd love to say that I made it up because then I'd feel like super smarty. I made it up not because it didn't exist before I made it up. I think what you're asking is it in the book? Yeah, there are exercises in the book that will include this and versions of this argument. But I just threw this one in the truth table because this is a pretty intuitive piece of reasoning. So remember, Boole doesn't come with any pre-existing files. You're always going to need to, create the sentences that you want. Yeah, okay? All right, so take a look at sentence 3. On what rows is sentence 3 false? 2, yep, and 4, yeah. Okay, now, you've identified the two rows on which we're calling C the conclusion, on which sentence 3, C, the conclusion, is false. Now, so we've just done, we've looked at a column and we've identified rows. Now cast your eyeballs across row 2, look at sentence 2, sentence 1. On row 2, is it the case that both sentence 1 and 2 are true? Both sentence 1 and sentence 2 are true. And not Evelyn, not Michelle, because Michelle's back there. Michaela's here. Jenny, what is my problem, Jenny? Okay, sorry, Jenny. Jenny, are you comfortable that, let's see, so we're at row, am I in your way here, or can you see? Okay, so we're at row 2, sentence 1 is true, sentence 2 is, yeah. So I think you might have been looking vertically, yeah? Okay, good, so this is great, you share this so that you don't get confused by looking in a different place from the one where I'm hoping you'll look. So, sentence 3 is false, 1 is true, 2 is false. Question for you. An argument is invalid when the sentences are, the premises are invalid. True, cause he's whispering, cause says the premises are true and the conclusion is false. Does this ring some bells? An argument is valid when it is impossible, I'm stressing the word impossible, it is impossible for the conclusion to be false if the premises are true. So what I'm doing now, mental twister here, we're juggling values. I'm saying, okay, well, is this argument invalid? Is there a row on which the conclusion is false while the premises are true? Sentence 2 is a possibility, but notice that, row 2 is a possibility, but notice that sentence 2 is false. So no problem there. Now look at row 4, false conclusion. Are both premises true? No, false, true. Okay, now this is gonna make you feel perhaps like you're playing mental twister. But I want you to try this. Is there a row on which the premises are true while the conclusion is false? You're gonna say no. That means there's no possible world where the conclusion is false while the premises are true. In other words, it is not possible, there is no world, it is not possible for the conclusion to be false while the premises are true. What is the one world where the premises are true? Which row? Yeah, row 3, premises are true, but so is the conclusion. The argument is valid, which is to say, in the case of truth table functions, the third sentence is a tautological consequence of the first two. So we can go under assessment, we can click is, and we're not going to worry about the others. And we verify and we're correct. Right, so I said we're not going to worry about the others because I'm only asking us to work the that last sentence as a consequence. Okay, how are we doing with this? Pretty okay? Notice you're building on what we were working on in chapter 2. All right, now just to bolster, I hope, your understanding, I'm going to leave everything the same except I'm going to switch. I'm going to leave most everything. Now, because I have altered our argument, we've got to recalibrate, if you will. So A is now the sentence that does not have a connective, right? Which means we do what with the values under A in sentence number 2? Copy them over. True, true, false, false. All right, now, what about not B? False, true, false, true. All right, hold tight. Is there a row on which the premises are true while the conclusion is false?
Yes.
Yes, row number? You're looking at true, true, true. Row number 1, true, yeah, you're exactly right. Row number 1 sinks the argument. Now, you might say, but Mia, row number 2 has all true premises and a true conclusion. It doesn't matter. You fail once on the truth table, the argument fails. Now, this is significantly important to work we're going to do starting in chapter 6, namely, if we want to use a piece of reasoning as a rule, and if we also want to prove a rule we're using, right, we can't use a rule that doesn't work all the time. For an argument to be a rule, it's got to be valid. It can't fail even once. Okay? So we go under assessment and we say that the last sentence is not a tautological consequence of the others. Remember, I'm ignoring everything else for right now. And then we verify and we get, yay, correct. Okay, now, before moving on to Alejandro's great question, let me just very quickly remind us of what we've done. We've reviewed a bit, right, from chapter 3. Then what we haven't done in let me review what we've done. In chapter 4, we've begun to make inroads into logical possibility, a logical necessity, and logical consequence. More specifically, we've talked about contingently true or truth table true sentences, that is truth table possible sentences, I meant to say. We've also talked about truth table true tautologies, right? So tautologies, which are true on every row of the truth table. And then we've talked about consequence, right? In other words, whether or not the argument is valid. So we'll come back to that and keep fleshing it out with some reference also to Tarski's rule. Let's just end real quick so that you can keep working forward in exercises with addressing Alejandro's great question. All right, so Alejandro says, hey, what do we do when we have more than 2 connectives? Or more than 2 atomic sentences. So let's say you have 3. So let's just say that we've got A, B, and C. Oops. Okay. The number of rows you will generate is determined by the number of atomic sentences you have. And the formula is, that's what's at the tippy top of the board under chapter 4. The number of rows is determined by multiplying 2 exponentially, that is 2 to the number of atomic sentences. So if, like me, you were real unhappy with certain features of math, like, oh no, this is calculation. Well, short story is this, even though there are exercises where you're asked to construct the possible values yourself, you could tell Boole to fill the reference columns for you, and notice you're given 8 rows, right? So it's 2 to the 3rd power. Why to the 3rd power? Because we have 3 atomic sentences.